In this video, I want to do a numerical example where I'll calculate income and substitution effects using a demand function. So let's suppose we have good 1 and good 2. Good 2 will be a composite good, so it'll just represent the money that we spend on all other goods after spending our money on good 1. So let's take a demand function. Let's say the demand for good 1 is represented by x1 equals 10 plus our income m divided by 10 times p1. And let's suppose that we have the income m of $120, 120, and that the price of good 1 starts out at $3. So what's our demand for good 1 at this original budget constraint? We would have x1 equals 10 plus 120 divided by 10 times 3, which is 10 plus 120 over 30, which is 10 plus 4, or 14. We get 14 units of x1 under the price of good 1 being $3. And then how much money is left over? So that's our x2. x2 will be 120, our income, minus our expenditure on good 1, which is we buy 14 units at a price of 3. So it'll be 120 minus 14 times 3, which is 42. So total of 78. So that will be this first point here. We buy 14 units of good 1, and we have 78 units of good 2. 78. Okay, now let's go on to, let's see what will happen. I'll do this in blue here. What happens, I want to know what happens when the price of good 1 falls. So P1 will fall to $2. We still have an income of 120. What's our demand for good 1 and good 2? We know that x1 is 10 plus m, which is still 120, divided by 10 times p1, which is 2 now. So we get a demand for a good 1, which is 10 plus 120 over 20, or 10 plus 6, which is 16. We get 16 units of good 1. How much good 2 do we get? x2 is 120, our income, minus our expenditure on good 1. We get 16 units at a price of $2 each, which is 120 minus 32, which is 88. So that's the second point here. We get 16 units of good 1, 88 units of good 2 after the price change. Now the trick is here, we want to decompose this shift into an income effect and a substitution effect. We're going to start with a substitution effect. Substitution effect says, consider these same relative prices as what we end up with, but let's back it up. Let's say we don't have the income effect. We don't have the purchasing power effect that makes us richer because the price of good 1 has fallen. Let's take our income back. Let's say we have the same purchasing power as our original bundle. What changes with respect to our demand for good 1? That's the substitution effect. So I'll do it in pink down here. Substitution effect says what we have, what we need to do is we need to lower the purchasing power that we have. In effect, we have a lower income, and we want to know what is, what's that? Where's that pink dot? If we had that lower income, where's our demand for good 1 falling? So our just given those those changes to relative prices. So what is the m prime? I'll label this curve, that budget line m prime. M prime says we have a lower purchasing power. How much lower is that purchasing power? And what we'll do is we'll say we still want to go through this original bundle. So, but it's with these new prices. So our P1 will be $2, and we want to just be able to afford that original bundle of $14.78. So our new income, M prime, says we can just afford getting 14 units of good 2, which will cost $28, 28, plus 78 units of good 2, which costs $78, because good 2 is just money. And if we add those up, what do we get? 106. So that's, going from 106 to 120, that's how much richer in purchasing power we are made because of this fall of the price from $3 to $2. But we're still not done yet. We still need to find out where is this point? We know our new income, it's 106. And the question is, how much do we demand of X1 at this new price and this new income of 106? We just plug and chug. Our X1 will be 10 plus the new income, 106, divided by 10 times the price. Here, our relative prices are the new ones. So times 2. 10 plus 106 divided by 20 comes out to be, I need some calculator help here. Let's see. 106 divided by 20 is 5.3. Add that to 10, we get 15.3. And how much of good 2 do we have? That'll be our income, 106, minus our expenditure on good 1, which is 15.3, at a price of $2 per. Again, go to the calculator, 106 minus 15.3 times 2 comes out to be 75.4. 75.4. So that's our point right here in pink. 15.3, 75.4. And you can see, should make sense. After the relative prices changed, good 1 got less expensive compared to good 2, going from this original bundle to the new relative prices. And as a result, we got more of X1 and less of X2, which makes sense because that's the direction that the relative prices were encouraging us to go. And then going from, so that's the substitution effect right there, going from the pink point to the blue point is our income effect. Our income effect said, as a result of the changes in prices, the price of good 1 fell, price of good 2 stayed the same. We were in effect richer. Our money went further. And that income effect, the fact that we felt richer, led us to buy a little bit more X1 and a lot more X2. And so you can say here, our final answer would be, what we wanted to do was to calculate the income and substitution effects. So the substitution effect is that X1, especially for X1 here, that we went from buying 14 of X1 to buying 15.3 of X1. So our substitution effect is we bought 1.3 more units of X1. And our income effect is that we bought even more X1. We went from the pink line to the pink dot to the blue dot. We went from getting 15.3 units of X1s to 16 units of X1. So we got another 0.7 units of X1 just because we felt richer. So that's the final answer there. And so we can see the income effect is positive, which implies we know that X1 is a normal good. It's a normal good. Demand, do two Ds for demand. Demand increases when income increases, which we already knew. We had a formula for demand for X1. It's 10 plus M over 10P1. M is in the numerator, so a higher income means a higher demand for X1. So we actually already knew that X1 was a normal good.